Section 2, Video 4, Operations with Radicals. We're going to first talk about addition and subtraction. So to do addition and subtraction, we just need a couple key things to be understood. Radicals are like variables with coefficients. So for example, if I gave you 2x plus 3x, you know that you have 5x. The same would go for this example here. You have the same radicals, so it's like having negative 2x minus 3x. If they are like radicals, then you can combine them as if they were like terms. So this would be a negative 5 root 5. So that's an example of treating them like terms. Okay? You can only add and subtract like radicals. So for example, if I had 2x plus 3y, you're done. There are no like terms. It's considered finished. So keep that in mind. But before you decide if they're the same or different, and if you should stop or continue, you have to make sure that your radicals are simplified. Because maybe they are the same, but they are not simplified. So with that said, if we look at this next question, we say to ourselves, are they all like terms? And we say yes. So we have a negative 1 here, a 3, and a negative 3. Combine them all together, and you get negative 1 root 3. Now on the last one, you say, well, they're different. But are they simplified? So if you simplify them, and we know that we just worked on this, that the largest perfect square that goes into 12 is 4. The largest perfect square that goes into 27 is 9. So that gives us 2 root 4 root 3 plus 3 root 9 root 3. This is the process we used on a previous lesson. Root of 4 is 2. So we have 2 times what was already out there, 2, and we get 4 root 3 when simplified. Here we have root of 9 is 3. We already have a 3 on the outside, so when you multiply them, you get 9 root 3. So after simplifying, we notice that, well, we do have the same root. They are like terms, so we can combine like terms. So the like terms get added, and we get 13, and root 3 stays the same. It does not change because we're approaching them as if they were like terms. So if it would be like saying 4x plus 9x. So we have 13x. But in this case, it's a root that there is 13 of. So 13 root 3. And this ends Section 2, Video 4.